Good day friends, welcome to my channel lecture series on power electronics. In this lecture we will see the principle of operation and construction of three-phase transformers and induction motors. Both transformers and induction motors work on the principle of electromagnetic induction. Let us say what this electromagnetic induction is. If you see in this picture, there are two coils, both wound on a soft iron core material, and if in coil 1 a AC voltage is given, there will be a current flow through the coil. There is another coil adjacent to this coil, and if we have a galvanometer connected to it, we will see that there will be a deflection in the galvanometer when the voltage is applied here. Why this happens is because when AC voltage is applied, there will be a current flow through the coil which will produce a magnetic field in this coil, and this will be associated with the adjacent coil. Though there is no electrical connection between these two, there is a voltage induced in the second coil. This is called as mutual induction. There is no electrical connection between the coil 1 and 2. So the voltage is induced in the second coil. This is the principle by which the transformer as well as the induction motor works. So the transformer operation is explained here. Here we have two coils, and one coil is having 1000 turns, the second coil is having 100 turns. If a AC voltage is applied, say 2000 volts to this coil, there will be a voltage of 200 induced in the second coil. That is, here for every turn there is a voltage of 2 volts. So on the secondary side also, for every turn 2 volts will be induced. So an EMF is induced in a coil when a current in the neighboring coil changes. The transformer works with alternating current supply only, which in nature itself is alternating in nature, which has a positive and the negative half cycle. The AC voltage is changing with respect to time. So a change in the flux is also observed in the second coil, which induces a voltage in it. This is the principle of a transformer. So if we see a single phase transformer, it has a core. One coil is wound on one of the limbs. On the second limb, another coil is wound. If the current is passing through the primary coil on application of AC voltage, there will be a flux produced in the coil, and that will be associated with the second coil also, and naturally there will be an EMF induced in the second coil. So the magnetic flux linked with the secondary coil changes, which induces the EMF in the secondary, and transformer works only with the AC supply. So for the mutual induction to happen, the flux should be changing with respect to time. The transformer cannot work in DC because a steady flux only will be produced if we give a DC voltage. The representation of a single phase transformer is shown here. The primary winding has more number of turns than the secondary winding if it is a step down transformer. If it is a step up transformer, the primary winding has got less number of turns in comparison with the secondary winding. So if in a single phase transformer we have primary winding and the secondary winding, in the three phase transformers also you have primary as well as the secondary winding. In a single phase transformer there is just one coil in the primary and one coil in the secondary, but in the case of a three phase transformer, three coils are present in the primary, three coils are present in the secondary. They are connected based on the need, either as delta connection or star connection. The line, two lines here indicate the core, three lines here indicate the core of a three-phase transformer. So a three-phase transformer, when it is connected in this fashion, it is called as delta star. So the combination is possible as star delta, star star delta delta for a three-phase transformer. So this is the star delta three-phase transformer. The primary is connected in star, secondary is connected in delta. So here, if this is again delta star. A three-phase transformer delta star connection type is shown in this picture. The primary winding is delta connected, the secondary winding is star connected. If the same arrangement is made in the form of a machine, say this delta connected primary winding is put in the stator of a machine like this, and a three-phase supply is given to it, this becomes the stator of an induction motor. And if the secondary winding is put inside the machine like this as a rotor, and the ends of the windings are shorted using slip rings, this becomes a slip ring induction motor. This shows a three-phase induction motor which has a delta connected winding, three-phase winding in the stator, to which a three-phase supply is given, and this rotor is star connected. The ends of the star connected winding are shorted using slip rings. The primary winding of a three-phase transformer is equivalent to the stator of a three-phase induction motor. The secondary winding of a three-phase transformer shorted using slip rings becomes the rotor of the slip ring induction motor. There are two types of three-phase induction motors. One is called the wound rotor induction motor, normally referred to as WRIM, or slip ring induction motor, SRIM, both mean the same, which has a wound rotor, that is a three-phase winding shorted using slip rings in the rotor. The second type is the squirrel cage induction motor, normally referred to as SGIM. The squirrel cage induction motor is the one very widely used. The stator of the three-phase induction motor looks like this, and here there is a winding shown. This is a three-phase winding. It can be either star connected or delta connected. And if the rotor is the one having a star connected winding shorted at the ends, it is called as the slip ring induction motor. We can have another type of rotor also, that is called as the cage rotor. The cage rotor looks like this. It will have number of copper bars all connected at the end using end rings. If such a rotor is present inside the machine, it is called as a squirrel cage induction motor. If we have three windings connected in star, the ends being shorted using slip rings, and it is called as slip ring induction motor. The slip ring induction motor rotor looks like this. There is a winding and you can see the slip rings over here. It can be directly shorted or it can be shorted using external resistances. The slip ring induction motor is capable of producing high starting torque. This is a squirrel cage rotor and this is having a low starting torque, but this is the one very widely used. The representation of a squirrel cage induction motor is shown here. The stator here, as it is three windings connected in delta and the three-phase supply is given. The rotor is shown as a circle with small circles which represents the squirrel cage rotor. This is the representation of a slip ring induction motor. Here the stator is shown, rotor is a winding which is shorted using slip rings, and the ends can be either shorted directly or through variable resistors. Both induction motors and transformers work on the principle of induced voltage. Transformer has the when voltage is applied to the primary winding, produces an induced voltage in the secondary winding. Similarly, in induction motor, when voltage is applied to the stator windings, it produces an induced voltage in the rotor windings. The difference is that in the case of induction motor, the secondary windings or the rotor can move, but in the case of a transformer, the secondary winding does not move. Due to the rotation of the rotor, the induced voltage in the secondary winding will not have the same frequency as that of the stator, whereas in a transformer, the primary voltage and the secondary voltage will have the same frequency. So this is the principle of operation and the construction of two different types of three-phase induction motors. Thank you.